Finally, we'll take here a torsion member subjected to a certain torque and is meshed with a gear. We can visualize here two gears, gear B and C are meshed. So we have given here one shaft AB and gear is mounted at B. Then this gear is meshed with the gear C, and the diameter of the gear B and the gear C are given, that is the P circle diameter are given. The diameter of the gear C is equal to 130 mm. Diameter of gear B is equal to 45 mm. The length of the shaft AB is equal to 600 mm. The diameter of the shaft AB is equal to 20 mm and the length of the shaft CD is equal to 900 mm and the diameter of the CD is equal to 25 mm. This one is the support, that is the bearing is provided at the A, and at point D we have fixed support. So the angle of twist at point D will be 0 because of we apply the torque here. Certain torque is transmitted because of a tangential thrust. So we can compute here what is the torque developed in the gear C, and the same torque will be applied to the shaft CD. First step, we'll find out here what is the torque applied. This torque applied equal to 63. Same torque will be available at B also. Then the torque will get multiplied at gear C. Then we'll calculate that torque. That torque will be same as equal to the torque for the shaft CD. Using that torque, we can calculate the angle of twist at point C with respect to D. Then using the kinematics of a gear, we'll find out here what is the relative position change for the gear B, and then using this torque we can calculate here what is the relative angle change of B with respect to A, and finally we'll find out the relative angle of twist at A with respect to D. So step by step we have to solve this problem. Value of G is given as 77, allowable shear stress is given as 55 megapascal, externally applied torque equal to 63 Newton meter. We want to find out the angle through which the end A of the shaft AB will rotate. If we apply a torque is equal to 63 Newton meter to the shaft AB, then how much torque is available for the shaft CD that you have to calculate. For this one, we'll first consider the FBD and we'll apply the static equilibrium condition. So we'll show here the gear B and we'll show the gear C. We'll draw the FBD, so we'll show the action and reaction. This time the gear B is rotating in a clockwise direction and torque for the shaft AB is same as equal to T is equal to 63 Newton meter. Because of this torque, the tangential thrust is developed, and the tangential thrust developed will be in the exactly opposite direction. The action and reaction takes place. B is rotating in a clockwise direction, the gear CD will rotate in the anti-clockwise direction. So this one is a driver this time, and in the case of a driver the tangential thrust will act in a direction opposite to motion, and this one is a driven. In the case of driven, the tangential thrust will be act in the same direction, anti-clockwise direction, and for driver it will act in a opposite direction. So tangential thrust, that is the tangential force, will show in the downward direction for driver, which one is opposite to the direction of rotation, that is a clockwise direction, and for driven will show in the same direction, that is action reaction. At the gear C we have, so let's consider the gear B only here. The gear B is a driver here, and therefore the direction of the force will act in the opposite direction. This one is same as Ft. So summation of the moment about the point B must be equal to 0. We have torque is clockwise, will be taken as positive, and F into R will be taken as negative. So in this case we have torque AB minus the force multiplied by the diameter divided by 2 will be the tangential thrust. Diameter is dB divided by 2 equal to 0. Torque is equal to 63 Newton meter minus F. Diameter you have to take in meter, and the diameter of the gear B is equal to 45 mm is same as equal to 0.045 divided by 2 must equal to 0. From this one we'll get the value of F, that is the tangential force, and this force is the action, so reaction will be exactly opposite. Solve this equation, you will get the value of F is close to 2800 Newton. Now we can use this value to find out the torque at CD. So the torque CD will be same as equal to F multiplied by diameter of gear C, that is DC divided by 2. we have F is equal to 2800 and the diameter DC is equal to 130 mm is 0.13 divided by 2. So we can very well calculate what is the torque on the shaft CD. So the torque on the shaft CD will come out to be 182 Newton meter. The torque on the shaft AB is used to calculate the rotation of A with respect to B is equal to 63 Newton meter. A is 63 Newton meter. And the torque on the shaft CD, this value is used to calculate twist of point C with respect to D, and the twist at D will be equal to 0. So that value is equal to 182 Newton meter. So this value is used to calculate the theta of B with respect to A, and this value is used to calculate theta of C with respect to D. But these two gears are in mesh. As the gear C will rotate, the gear B will also rotate. So required here kinematic analysis of a gear. So that is our second step. So we can very well calculate what is the twist between B and A, that is theta B minus theta A. We'll be using the equation of a torque AB. We can calculate theta B with respect to A. Theta C with respect to D will be same as theta C minus theta D. Out of that, we have theta D will be equal to 0. Only thing here is that we want to relate the value of theta B and theta C. So again we'll consider here the mesh of the two gear B and C, and we apply here the kinematic analysis to relate the angular rotation of the gear B and the gear C. Since here two gears are in mesh, so both the gears will travel the same linear distance. In that case, radius multiplied by the value of theta C will be same as equal to the radius of the gear B multiplied by theta B. So from this relative position, the theta B will measure in this direction, that is the same direction of the rotation of the gear B. Let's call this value is equal to theta B. In the similar way, the gear C will turn in the opposite sense, and the angle turned by the gear will be equal to theta C. So we'll get the relation between theta B and theta C. Hence we can calculate the value of theta A. Linear distance traveled by gear B and the gear C remains same. Linear distance is same as the product of angular distance multiplied by radius. So we have theta B and the radius will be equal to dB divided by 2 is same as equal to theta C multiplied by diameter of C divided by 2. 2 and 2 will be cancelled out. So we get a relation here between theta B. We have theta B is equal to dC divided by dB multiplied by theta C. So we have theta B is equal to diameter of the gear C is equal to 130 and B is equal to 45. So we have 130 divided by 45 multiplied by theta C. That is, we have theta B is close to 2.8 times of theta C. So this is another equation we are having, that is we have theta B is equal to 2.8 times theta C. Now theta B with respect to A can be calculated as TAB into L of AB divided by JG, and theta C with respect to D we can calculate as torque multiplied by length divided by J divided by G, and finally we can use the last equation, that is theta B theta C, and we can comfortable to calculate the value of angle of rotation at point A. In the step number 3, we'll calculate here theta B with respect to A. For that one we'll use a simple formula, that is theta equal to torque multiplied by length divided by J divided by G. So theta A with respect to B is a torque in the shaft AB multiplied by the length of AB, that equal to 600 multiplied by the polar moment of inertia is pi by 32, 20 to the power 4 divided by G is equal to 77. So let's substitute here. This value we can write as theta A minus theta B is equal to torque AB equal to 63 Newton meter. So we have 63 Newton meter will multiply by 10 to the power 3 Newton mm. Length of AB is equal to 600 mm. Polar moment of inertia is pi divided by 32. 32 will shift in numerator, and we require the diameter of AB that equal to 20. So we have 20 to the power 4 is further divided by G. Value of G is equal to 77 gigapascal. So we have 77 into 10 to the power 3. Solve this equation and you will get this difference of theta A minus theta B is equal to 0.03125 radian. Now same thing will repeat for C to D. So we have theta C with respect to D is a torque of CD multiplied by length of CD divided by the polar moment of inertia of CD multiplied by value of G. Now theta C with respect to D is theta C minus theta D, and theta D is equal to 0 because D is the fixed end. So TCD, that is the torque in the shaft CD, is equal to 182 Newton meter. That you have to use in mm, so you have to multiply by 10 to the power 3. Then we require the length of CD. Length of CD is given as 900 mm. Then we have polar moment of inertia is pi. 32 will shift in numerator, and we have diameter of CD that equal to 25. So we have 25 to the power 4, and the value of G is remains same, that is 77 into 10 to the power 3. So we have theta C minus 0. So this value is the absolute value of theta C, and this value of theta C come out to be 0.055 radian. Now we know the value of theta C, and we have a relation between theta B and theta C, so we can calculate here value of theta B. So we have theta B is equal to 2.8 times of theta C, that is we have 2.8 times of 0.055, that is equal to 0.1553, that will be radian. Now we'll use the equation number 1 here to calculate the value of theta A. So we have theta A minus theta B is equal to 0.03125. Theta B will be added on this side. So we have theta A equal to theta B is 0.1553 plus 0.03125. So this one is the absolute angle of twist at A with respect to D, and this value is close to 0.1865, that will be radian. If you want to convert into degree, you have to multiply by 180 divided by pi. So finally we'll get a twist of 10.68 degree. In the gear system shown in the figure, the motor applies a torque of 600 Newton meter to the gear at A. So this one is the motor shaft. Then we have gear A which mesh with the gear B. Gear A has a teeth equal to 24. Gear B has a teeth equal to 72. Gear B and gear C are mounted on the same shaft. That is, the number of teeth of gear C is equal to 30. Gear C mesh with D. The gear D has a teeth equal to 60. D and E, they are on the same shaft. This one is called as shaft 1 and this one is shaft 2. We want to find out here the torque T provided by the gear system at gear E. If the allowable shear stress in each shaft must be limited to 70, determine the minimum permissible diameter for each shaft. So for shaft 1 and shaft 2, we have to find out what is the diameter D1 and D2, and permissible shear stress is given as 70 megapascal. In addition to this, the torque at gear A is equal to 600 Newton meter, and the torque at gear E you have to find out. So we'll make here the relation between the torque and the number of teeth. For this one, we'll consider here two gear in mesh. Let's say this one is gear 1 and this one is gear 2. We have force is equal to F. This is also force. Action and reaction are the same forces. This is subjected to the torque equal to T1. So for the gear 2, we have torque is equal to T2. Let's say here Z1 represents the number of teeth of gear 1 and Z2 represents the number of teeth of gear 2. Since these two gear are in mesh, their module is same. So P circle diameter of gear 1 is D1 is given as M into Z1, and the P circle diameter of gear 2 is given as M into number of teeth of gear 2, that equal to Z2. In this case, we have torque T1 is same as equal to the force F multiplied by D1 divided by 2. And here we have the torque T2 will be equal to force F multiplied by D2 divided by 2. So from this equation we can find the value of F is equal to 2 times of T1 divided by D1. And this value of F we can use in this equation. In that case we have T2 is equal to F is replaced as 2 times of T1 divided by D1 multiplied by D2 divided by 2. Here 2 and 2 will cancel out, and we get the value of T2 is equal to T1. D2 we can write as product of module multiplied by number of teeth Z2 divided by D1 we can write as module multiplied by Z1. That is, we have T2 is equal to T1. This value of Z2 I will write in the denominator of T2, and Z1 will write here in the denominator of T1. So this is the relationship for us in between the torque and the number of teeth. So if I write this generalized relationship for the gear A and the gear B, I can write this value as TA divided by ZA is same as equal to TB divided by ZB. Here gear A and B are mesh, so we can use this equation. Here gear C and D are in mesh, so we can write as torque for gear C divided by number of teeth for gear C is equal to torque at gear D divided by number of teeth for gear D. Secondly, we have given the torque for the motor. Motor torque is same as equal to the torque for A. So in this case we have motor torque Tm will be same as equal to TA, and this value is given to us equal to 600 Newton meter. Then the torque for gear B is same as torque for gear C and is same for the shafts BC. So we have torque for gear B is same as torque for gear C is same for torque for shaft BC. Here we have the torque for gear D is same as the torque for gear E is same for the shaft DE. So we have torque for gear D is same as the torque for gear E is same as the torque for shaft DE. In addition to this, we have given the value of tau allowable, that equal to 70 megapascal. So we have tau allowable is given as 70 megapascal. So this equation we have proved. We'll use this equation to find out the value of TB. Once we know the value of TB, we know the value of the torque carried by the shaft BC, and using the torque formula equal to pi by 16 dq, we can calculate the diameter of the shaft 1. Then using the value of ZD, which is same as equal to the torque for the shaft DE, we can calculate the shaft diameter equal to D2. Diameter of the shaft 1 you have to find out, diameter of the shaft 2 you have to find out, and the torque E you have to find out. So we can use this equation here, that is a torque at A divided by number of teeth of gear A equal to torque of gear B divided by number of teeth for gear B. So we have TA divided by ZA is same as equal to TB divided by ZB. So from this we'll get the value of TB is equal to ZB divided by ZA multiplied by TA. So let's substitute for ZB. ZB is equal to 72. ZA is equal to 24. And we have torque A is equal to 600. 72 by 24 is 3. 3 multiplied by 600, that will be equal to 1800 Newton meter. So this one is torque for B. This one is same as the torque for gear C also, because it is mounted on the same shaft, and is the same for the shaft BC also. Now since here we are knowing the value of the torque carried by the shaft BC, that is the shaft 1, we can find out here the diameter D1. So we have torque for gear BC is same as equal to pi divided by 16 into D1 cube multiplied by allowable shear stress. That is equal to 1800. 1800 is Newton meter. So we will multiply by 10 to the power 3 is equal to pi divided by 16 into D1 cube multiplied by allowable shear stress is given to us equal to 70. From this we will get the diameter D1, which one is the minimum diameter, should be equal to 50.8. Any diameter above 50.8 will safely have the shear stress less than 70 megapascal. Now we'll go for the second equation, that is we have torque at gear C divided by number of teeth of gear C is equal to torque for gear D divided by number of teeth of gear D. TC is known to us, that is equal to 1800. So from this equation we can calculate the value of TD. So we have torque or gear D is equal to ZD divided by ZC multiplied by torque for gear C. Number of teeth for gear D is equal to 60 and the number of teeth for gear C is equal to 30, and we have torque for gear C is equal to 1800. 60 divided by 30 is 2. 2 into 1800 is equal to 3600. That will be Newton meter. So this one is a torque for gear D. Is same for the torque for gear E because they are mounted on the same shaft. Is same as the torque for shaft DE also. Now once we know the value of the torque DE, we can use the formula as pi by 16 into D2 cube multiplied by allowable shear stress. From this we can find out the diameter of the shaft 2. Torque for DE is equal to 3600 Newton meter. So we have 3600 multiplied by 10 to the power 3 will convert into Newton mm. We have pi by 16 multiplied by D2 cube, and we have allowable shear stress is equal to 70. Solve this, we can obtain the value of D2. The diameter D2, that is the minimum diameter, is close to 63.98. That will be mm. So minimum value you have to select as 63.98. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.